This video is over adding and subtracting rational expressions. Anytime you are adding or subtracting fractions or rational expressions, the denominator has to be the same. So if we have AC plus or minus BC, we can add the numerators and keep the denominator. Now with rational expressions, we have to find the least common denominator, just as if we were working with fractions. Let's look at a fraction example. So we have 7 over 10 plus 4 over 15. We need the common denominator. So what I do is choose the largest value in my denominator, which is 15, and I count by 15 until I find a value that 10 can divide into, which in this case is 30. Or if you want to look at this by like a rational expression method, 10 is 2 and 5, 15 is 3 and 5, so we factored our denominator. And for our LCD, which this is the same concept as our rational expressions, we will write the factors of the first denominator, and then we will take any factor that is different in our second denominator and write it down. So since we already have a 5, we'll write the 3. So if you multiply all that together, we actually get the number 30. So this is the same concept that we will use for rational expressions. Now that our LCD is 30, we need to rewrite these fractions so that they are similar to what we had before. So 10 times 3 gives us 30. So whatever we multiply downstairs, we have to multiply upstairs. So 7/10 is the same thing as 21/30. Same thing with 15. If we multiply by 2, we get 30. We have to multiply the numerator by 2 as well. So we get 29 over 30 when we add 7/10 and 4/15. So let's go ahead and do the rational expressions. The first one I'm going to show you, I'm going to write it all out, and this next preceding examples I'm going to show you, I'm going to be more efficient in the way I write my work. So let's look at this first problem, which we are adding two rational expressions. Now, just like we did on our fractions, we factored them, and we could see each of the different factors we had. Well, that's the same thing we're going to do with this one. We are going to factor the denominators so that we get the least common denominator. So to find the least common denominator, you're going to write everything you have in our first denominator, every factor. So we have x and x minus 2 as factors. Then we look at the second denominator and pick anything that is different. So x minus 2 and x minus 2, we already have an x minus 2, so there's no need to repeat that one. But we don't have an x plus 3. To make sure that you have the least common denominator, if you cover up any of the factors, you should get back what you started with. So I covered up the different factors. I can cover them up to get that denominator back. So I have the least common denominator. Next, what we're going to do is rewrite our fractions. So we are going to write these separately. later on. I'm not going to write these separately as it causes too much work, but if you want to go ahead and do this on your examples, that is fine with me, as long as you're understanding the concept. Now, between the original denominator to the new denominator, we have to look at what's missing. Well, this factor here is missing. So we have to multiply the numerator by x plus 3. So this fraction is the same thing as this fraction if we cancel the x plus 3. So essentially we are uncanceling or unsimplifying our fractions, or writing similar fractions. Between these two, we are missing this x. So to fix this, we multiply the denominator by x. Well, we have to multiply the numerator by x. So we'll get 5x squared. Now that our denominators are the same, we write our answer as one denominator, and then we add the numerators. Well, here we have to do a little work with distributing that 3x, and then we have a positive 5x squared. I'm going to go ahead and reorder my terms in the numerator so they are from least to greatest. This is prime. It will not factor. If you go and look at my primability video, that will explain. And we are finished. Now, do not ever multiply this out. Keep them as factors. That will be the simplified version of your answer. If you go and multiply this all out, then you will, well, it's not simplified then. Sometimes it's good to do that, but other times it's just way easier just to leave it be, and it's less work for you as well. So 13 over 3x minus 15 minus 5x over x squared minus 25. Now this one, I will not write my two fractions out like this to where they are equivalent fractions. What I'm going to do is have something that kind of looks like this, or at least have these two in one numerator, and then go into simplifying my numerator. So the first thing we need to do is factor our denominators. So our denominators are factored. Now our least common denominator, we will write everything we have here in our first denominator, and our second denominator include anything that we don't have. So we do have an x minus 5, but we don't have an x plus 5. So our least common denominator is 3 times x minus 5 times x plus 5. And again, I can create or recreate both of my denominators by covering up the extras. And if you cannot create your denominators by covering up extras, then that just means you're missing that factor. Okay, so between this denominator and the new denominator, we are missing x plus 5. So we must multiply the top by x plus 5. Because essentially, whatever you do downstairs, you have to do upstairs. So I'm going to write this as 13 times x plus 5. And this, think of this as a negative 5x when we work this. So the denominator has to be the same. Well, we're missing the 3. If we multiply 3 by the denominator, then we will have our LCD. Well, whatever you do downstairs, you have to do upstairs. So this will be a negative 5x times 3. That will give us a negative 15x. It's always good to include the subtraction sign. Just give it to the value that is behind it, and then that will give you the correct sign that comes next, especially if R3 had to become negative for some reason. And then what we're going to do, instead of writing this out a lot of times, I'm going to just focus in on my numerator. So I have 13x plus 65 minus negative 15x. And then I'm going to go ahead and simplify this further. So we have a negative 2x plus 65. This we cannot factor. If we were to factor it, it would probably be the greatest common factor, but 2 can't go into 65. So then I am finished, and I'm going to finalize my answer by placing my denominator in place, and I'm done. Two over x plus 3 plus x over x minus 6. Our two denominators are prime, or they are their own factors. So our LCD is actually going to be each of those. And I didn't even write the LCD off to the side. It's just x plus 3 and x minus 6. And then what we're going to do is we have to multiply this first one by x minus 6 for it to match, and x plus 3 for the second one to match. And whatever you do downstairs, you have to do upstairs. So then we have 2x minus 6 plus x times x plus 3. And yes, instead of writing that all out as I did, you could have went ahead and distributed each of those. That would have been more efficient. I'm not going to worry about my denominator yet. I'm going to add like terms. Factors of 12 that add to 9, or to add to 5, excuse me, there are not any, because you have 1 and 2, or 1 and 12, 2 and 6, 3 and 4, so none of those add to 5. So that is prime. And then we write our denominator so that we have a rational answer. Okay, let's subtract these two. So first we have to factor. So we know what factors make up our trinomials. Okay, so for the least common denominator, you are going to copy the first denominator. The second denominator, as you can see, we have x minus 1 times x minus 1. You're going to treat these like twins. So each of them is their own identity. So x minus 1 and x minus 1, if you look at our LCD so far, we have an x minus 1, so we can match one of the x minus 1s, but we are missing this twin, so you have to include it. Again, to figure out if you have the LCD, you can cover up any of the ones you want or need to match your original denominator. If I cover up the middle one, I have my second denominator. Okay, so it's very important to include both of them. Now, going on, and on this one, since we have two x minus 1s, I can write that as x minus 1 squared. And it doesn't matter how you write them. So with the first one, you can see that we are missing the x minus 1. So I'm going to go ahead and distribute that 2 through. And then we have a negative 5x, and as you can see, we are missing the x plus 1. So include the negative, so negative 5x squared minus 5x. Always include the sign in front of your term. Otherwise, you are changing the problem. And before I finalize my answer, I see that all of these are negative. I can factor out a negative to make it a little more simple, and then include my denominator, and we are finished with that one. So keep in mind that if you have a double factor, they are twins and they are their own person or their own factor. This concludes our video.